Okay, in this problem, what we need to do is we need to determine the empirical formula of a compound that contains carbon, hydrogen, and oxygen with the following percentages by mass. Now, before we start doing our calculations, there are a few important things that we need to remember. First, we need to go back a little bit and recall about the molecular formula. What do we understand from the representation of molecular formula, and then we'll talk about what is the empirical formula. First, if we have a representation of a molecular formula, when we look at it, we need to understand the following. We need to understand that 1 mole of this compound contains 4 moles of carbon, it contains 12 moles of hydrogen, and it also contains 2 moles of oxygen based on these coefficients, the numbers that are given here. So the important thing to remember is that these numbers, the coefficients, represent the subscripts, actually, not the coefficients, represent the number of the moles of each element in 1 mole of the compound. Now, what is the problem here? The problem is that it is given in percentages, and we cannot write an accurate molecular formula based on the percentages. So our aim here is to go from percentages to moles for each element. How do we go from percentages to moles? Well, the plan here is that we need to go from percentages to mass, and then from the mass we can go to moles. How is this going to happen? In order to do so, we need to assume a certain amount, a certain mass of the compound. And we can assume any amount of the compound, but for the convenience, we're going to assume that we have 100 grams of this compound. Why is it beneficial to assume 100 grams of a sample? Because if we convert these percentages to grams for a 100 gram sample, suddenly all of these numbers, the 18.75, 6.25, and 75, will turn into grams. And so why? Because what is the 18.75% of 100? It is 18.75. So if we have a 100 gram of a sample, now we can say that the mass of the carbon is equal to 18.75 grams. We can say that the mass of the hydrogen is equal to 6.25 grams, and we can also say that the mass of the oxygen is equal to 75 grams. So one important step here is that to assume that we have 100 grams of a sample, and we can just easily convert the percentages to mass. And then after that, we have one more step to do, go from the mass to moles. Well, how are we going to do it? We need to use this formula. We know that the moles are equal mass over the molar mass. And so knowing this, we can do the calculations and determine the moles of each element. So let's write this down. So we can write down that number of the moles of the carbon is equal to 18.75 grams divided by 12.0 grams per mole, molar mass of the carbon, and this is equal to 1.5625 moles. Now, one thing here is that I would advise ignore the significant figures for empirical formula calculations, because more numbers you have here, easier it's going to be determined to determine the empirical formula. So for a moment, let's ignore the significant figures and determine the moles of the hydrogen now. Moles of the hydrogen are equal to 6.25 grams divided by 1 gram per mole molecular mass. So we have 6.25 moles of hydrogen. This is carbon. And now we can also calculate number of the moles for the oxygen. So it's going to be equal 75 grams divided by 16 grams per mole, which gives us 4.687 moles. Now we know the moles of each element, and we can write down a formula for this compound. So let's put them in order. So let's write down this carbon, and I'm going to write down that the carbon is 1.5625 moles. Hydrogen is 6.25 moles, and oxygen is 4.8687 moles. So this is now a formula. It's a strange formula, and the reason is because we do not have whole numbers, right? So these are decimals, and in the formulas we don't have decimals or fractions. It should be simple numbers here. So how are we going to simplify these numbers? And depending on what numbers you get, there's going to be different ways how to simplify it. But one way that works almost all the time is to divide these numbers by the smallest number. So 1.5625 is the smallest number, so I'm going to divide everything by this number. Okay, so 1.5625. Now if I divide these, the reason we divide by the smallest number is that now we'll have carbon 1, and so H will be 6.25 divided by the smallest number, and so this is going to give us 4. And oxygen, if we divide the moles by this number, it's going to be 3. And so this looks a lot better now. It's a formula with simple numbers, whole numbers, 1, 4, and 3. And this is actually the empirical formula of this compound. Why? Because if you forgot, let's go back to the molecule that we drew initially. So we had C4H12O2. This is a molecular formula. The empirical formula is just the simplified numbers of the moles. So we need to express the formula in the smallest possible whole numbers. And the way to do it here is that we're going to divide everything by 2, because if I divide by 2, oxygen will be 1 mole. So carbon to H6 and O, this now will be the empirical formula. And so what we have here, 1, 4, 3, these are the possible smallest whole numbers. We can't simplify it any further because we have 1 here. So C1H4O3, this will be the empirical formula of this compound. Now to summarize a little bit, this is what you can do. If you are given the percentages first, you can assume that you have 100 grams of a sample. And here again, I want to mention one more time, you could have assumed that you have, let's say, 350 grams of the sample. It wouldn't matter. Then what you would have to do is you'd have to calculate the masses based on these numbers. You would have to calculate how many grams is 18.75% based on 350 grams, and same 6.25% for the oxygen. You'll get absolutely the same result, but it's just easy to assume 100 grams of the sample. Second, go with this plan. The plan is go from percentages to mass, then you go from the mass to moles. This is what you need to do if you have the percentages instead of the moles. Finally, if you get the representation and it's not a whole number, you would have to actually simplify it. So simplify. And so in order to simplify it, one way is to divide by the smallest number. Find the smallest number and divide by that, and you will get the empirical formula. So if you like this video, please subscribe to our channel, and you can visit chemistrysteps.com for more problems, discussions about chemistry.